The massive T-shaped pillars rose from the dusty earth like sentinels frozen in time. 12,000 years of silence. And now they spoke. Dr. Isabelle Ramirez stood motionless as the artificial intelligence system finished rendering its analysis on the screen before her. Her hand trembled slightly as she reached out to touch the monitor, almost as if she could physically grasp the revelation displayed in vivid color. "That cannot be right," she whispered. Behind her, Professor Ian Thorne watched with growing concern. "What is it, Isabelle?" She turned, her face pale in the blue light of the laboratory. "These symbols, they are not random. The AI has found a pattern, a message, something hidden in plain sight for 12 millennia." The laboratory fell silent except for the soft hum of computers. Outside, the Turkish sun beat down on the ancient site of Göbekli Tepe, the world's oldest known megalithic temple complex, built millennia before Stonehenge or the pyramids, a site that, according to conventional archaeology, should not exist. "If what this data suggests is correct," Isabelle said, her voice barely above a whisper, "we need to reconsider everything we thought we knew about early human civilization." Ian moved closer to examine the screen. "Are you telling me that hunter-gatherers, people who supposedly had not yet invented pottery or domesticated wheat, encoded a complex mathematical message into these stone pillars? That is impossible." Isabelle looked up, her eyes reflecting both wonder and apprehension. "Apparently not. And what they were trying to tell us might explain why this site was deliberately buried and hidden for thousands of years. The AI had uncovered something that human eyes had missed for centuries, a mathematical pattern encoded in the positions and carvings of the ancient stones. Not just any pattern, but a precise astronomical warning about a recurring celestial event, an event that happens to be due again in our lifetime. What the builders of Göbekli Tepe knew, and desperately wanted future generations to understand, was something so profound that it would challenge our entire conception of human history, cosmic cycles, and perhaps our very survival as a species. And we almost missed it entirely. The story of how artificial intelligence uncovered the secrets of Göbekli Tepe begins not in Turkey, but in a cramped university office in Boston in 2021. Dr. Rachel Brighton, an archaeoastronomer with a background in computer science, was reviewing satellite imagery of ancient megalithic sites when she noticed something peculiar about the layout of Göbekli Tepe's stone circles. The arrangement seemed intentional in ways that went beyond ritual purposes, Rachel explained during our interview. "I had this nagging feeling there was a geometric precision that served a specific purpose, like how Stonehenge aligns with solstices, but potentially more complex." Rachel had previously developed machine learning algorithms to identify patterns in archaeological data too subtle for human perception. Her work had successfully identified previously unknown settlements in Mesoamerica by detecting minute changes in vegetation patterns. But what she was about to attempt with Göbekli Tepe was far more ambitious. The site itself defies conventional archaeological understanding. Discovered in 1994 by German archaeologist Klaus Schmidt, Göbekli Tepe dates to approximately 9,500 BCE, a time when humans were supposedly primitive hunter-gatherers living in small, nomadic bands. Yet here was a monumental complex of stone circles containing massive T-shaped pillars, some weighing up to 20 tons, intricately carved with images of animals, symbols, and abstract designs. Even more baffling, the site shows evidence of having been intentionally buried around 8,000 BCE. The builders had deliberately covered their creation with thousands of cubic meters of soil and debris, preserving it but also hiding it from view. Why would they invest enormous resources and effort to create such a sophisticated complex, only to bury it? "That deliberate burial has always been the most intriguing aspect to me," said Professor Ian Thorne, director of the Institute for Computational Archaeology at Cambridge University. "It suggests they wanted to preserve something for future discovery, not just abandon it." Rachel's approach was revolutionary. Rather than focusing solely on the carvings as symbolic art, she treated the entire complex, its orientation, the positioning of pillars, the geometric relationships between structures, and the distribution of symbols as a potential dataset. Ancient peoples often encoded astronomical knowledge into their monuments, Rachel explained. But previous analyses of Göbekli Tepe had yielded inconclusive results. I believed we needed to look at it as a multi-layered information system, the way modern computers use various data channels simultaneously. Rachel partnered with Dr. Isabelle Ramirez, a specialist in ancient languages and symbolism who had been documenting the intricate carvings at Göbekli Tepe for the past decade. Together, they assembled the most comprehensive digital model of the site ever created, incorporating LiDAR scans, photogrammetry, and detailed cataloging of every carving and structural element. When Rachel approached me with this idea, I was skeptical, Isabelle admitted. I had spent years analyzing these symbols using traditional archaeological methods. The idea that AI could see patterns I had missed seemed far-fetched. Nevertheless, by the summer of 2022, they had completed their digital model and were ready to apply the specialized neural network Rachel had designed. An algorithm she called Chronos, Cultural Heritage Recognition and Organization of Nonlinear Symbolic Systems. What happened next would change the course of archaeological understanding forever. On September 17, 2022, Chronos completed its initial analysis of the Göbekli Tepe dataset. Rachel was alone in her office when the results came in, expecting another inconclusive outcome as with previous runs of the algorithm on smaller datasets. The system had been programmed to look for correlations between the positioning of pillars, the orientation of carvings, and potential astronomical alignments, all while controlling for random chance. Previous attempts at finding astronomical alignments at Göbekli Tepe had yielded contradictory results, with some researchers claiming alignments with Sirius, others with various constellations, but none presenting conclusive evidence. Rachel stared at her screen in disbelief as Chronos highlighted a pattern that no human researcher had previously detected. A mathematical relationship between the positioning of the central pillars in multiple stone circles that corresponded precisely to the motion of particular stars over a 26,000-year cycle known as the precession of the equinoxes. My first thought was that I had made a programming error, Rachel recalled. The precision was too perfect. Hunter-gatherers from 12,000 years ago should not have been able to calculate precession with that level of accuracy. The precession of the equinoxes is the gradual shift in Earth's rotational axis that causes the position of stars to change slowly over millennia. It takes approximately 26,000 years for this cycle to complete, a time frame far beyond a single human lifetime. Modern astronomy only began to understand this phenomenon accurately in the 18th century. Yet here was evidence that the builders of Göbekli Tepe had not only recognized this pattern but had encoded it with remarkable precision into their monument. Rachel immediately called Isabelle, who was conducting fieldwork at the site in Turkey. I remember the call clearly, Isabelle said. Rachel was speaking so fast I could barely understand her. She kept saying, "They knew, Isabelle. They knew about precession. They built a calculator." Within days, Rachel had flown to Turkey to meet Isabelle at the site. They spent 2 weeks verifying the findings on the ground, measuring angles and orientations to confirm what the AI had detected. Standing among those ancient stones, knowing what they represented, it was overwhelming, Rachel said. These pillars were not just ceremonial markers. They were a sophisticated astronomical computer built by people who, according to our previous understanding, should not have possessed such knowledge. But this was just the beginning of their discovery. As they refined the algorithm and fed it more detailed data, Chronos began to detect additional layers of information embedded in the site's design. The AI identified a second pattern related to a specific astronomical event, the periodic passage of a cluster of comets that intersects Earth's orbit approximately every 6,500 years. This comet cluster, now known to astronomers as the Taurid stream, is associated with periodic increases in meteorite impacts and cosmic debris entering Earth's atmosphere. Modern astronomy has only recently begun to understand the Taurid stream's significance. In 2019, a team of researchers published evidence suggesting that a significant impact event around 12,800 years ago, precisely when Göbekli Tepe was being conceived, may have triggered the Younger Dryas, a sudden cold period that potentially influenced the development of agriculture. The correlation was undeniable, Isabelle explained. The positioning of animal carvings on the pillars, which had previously been interpreted as totemic symbols, actually mapped the position of specific star clusters associated with the Taurid meteor stream, and the sequence of pillars appeared to track its movement over time. In other words, Göbekli Tepe was not just a temple or gathering place. It was a warning system, designed to track and predict the return of a potentially catastrophic cosmic event. As news of Rachel and Isabelle's preliminary findings began to circulate among their colleagues, the archaeological community reacted with a mixture of fascination and intense skepticism. The reaction was predictable, Ian Thorne recalled. When you challenge the established timeline of human technological development this dramatically, you should expect resistance. Dr. Marcus Heinlein, a prominent archaeologist specializing in Neolithic cultures, was among the most vocal critics. What Brighton and Ramirez are suggesting is archaeoastronomy gone wild. He wrote in a scathing email that later became public. They are projecting modern knowledge onto abstract symbols and seeing patterns that simply reflect our own astronomical understanding, not that of prehistoric peoples. Other critics pointed out that the precession of the equinoxes is an extremely subtle phenomenon, barely noticeable within a single human lifetime. How could prehistoric people without writing or advanced mathematics possibly track such a gradual celestial movement? Undeterred, Rachel and Isabelle continued refining their analysis. They invited a team of independent astronomers and mathematicians to verify their findings, implementing rigorous statistical controls to ensure the patterns were not the result of coincidence or cherry-picked data. By early 2023, their research had gained sufficient credibility that the Turkish government granted them expanded access to areas of Göbekli Tepe that had not yet been fully excavated. What they found there would silence many of their critics. In April 2023, excavations revealed a previously undocumented chamber beneath one of the peripheral stone circles. Inside was a set of carved limestone tablets featuring what appeared to be astronomical notations, dots and lines arranged in patterns that, according to Kronos's analysis, corresponded precisely to the positions of key stars over several millennia. These tablets were the smoking gun, Isabelle explained. They showed the same mathematical relationships that the AI had detected in the larger monument, but in a more explicit format. It was as if we had found their astronomical calculations. Carbon dating of organic material found alongside the tablets confirmed they were contemporary with the original construction of the site. Additional analysis revealed traces of ochre and other pigments that had once colored the carvings, suggesting they were meant to be highly visible instructional tools. As the evidence mounted, even skeptical colleagues began to take notice. Dr. Elizabeth Johnson, an expert in prehistoric mathematics who had initially dismissed Rachel and Isabelle's findings, conducted her own analysis of the tablet patterns. "I approached this with every intention of debunking it," Dr. Johnson admitted during a presentation at the 2023 International Archaeological Congress. "Instead, I found myself staring at what can only be described as a prehistoric astronomical calculator of extraordinary sophistication. The probability of these patterns occurring by chance is effectively zero." By mid-2023, a new consensus was emerging among researchers. The builders of Göbekli Tepe possessed astronomical knowledge far more advanced than previously thought possible for their era. But this realization only deepened the mystery. How did they acquire this knowledge, and why was it so important to them? The central revelation of Kronos's analysis came in July 2023, when the AI identified what appeared to be a timeline encoded in the sequential arrangement of pillars across multiple stone circles at Göbekli Tepe. This timeline tracked the motion of the Taurid meteor stream over thousands of years and appeared to highlight specific periods when Earth's orbit intersected more densely with this stream of cosmic debris, creating increased risk of meteorite impacts and atmospheric phenomena. According to this timeline, the period of approximately 10,900 to 10,500 BCE, precisely when construction of Göbekli Tepe began, marked one such dangerous intersection. More alarmingly, the encoded information pointed to another such period occurring in the early to mid-21st century, our present era. When we first realized what the timeline indicated, it was difficult to process, Rachel said. The idea that the builders of Göbekli Tepe were potentially warning us about an astronomical event in our future seemed like science fiction. To verify this interpretation, the research team collaborated with astronomers specializing in near-Earth objects and cometary orbits. Dr. Jonathan Rivera of the International Astronomical Union conducted independent calculations of the Taurid stream's orbit over the past 13,000 years. The correlation between our current astronomical models and what the Göbekli Tepe timeline suggests is remarkable, Dr. Rivera confirmed. We have known that Earth periodically passes through denser parts of the Taurid stream, but the precision with which this ancient site predicts these intersections is unprecedented. Modern astronomical observations have indeed confirmed that Earth is currently entering a period of increased interaction with the Taurid meteor stream. Between 2023 and 2030, our planet will pass through what astronomers call the resonant swarm of the Taurid complex, a denser concentration of cosmic material that could produce more frequent and larger meteoritic airbursts. This aligns precisely with the warning encoded at Göbekli Tepe, raising profound questions. How could its builders have calculated this with such accuracy? What exactly were they warning about? And what does this tell us about the true history of human astronomical knowledge? To answer these questions, Rachel and Isabelle expanded their research to include other ancient sites worldwide. They applied the Chronos algorithm to digital models of everything from Stonehenge to the pyramids of Giza to Nazca lines, looking for similar astronomical encodings. We found correlations, Isabelle explained, but none as precise or comprehensive as Göbekli Tepe. This suggests it was the original astronomical calculator, perhaps the source from which later monuments drew inspiration. This hypothesis gained support from an unexpected quarter: genetic studies of early agricultural communities. Recent DNA analysis has shown that the people who built Göbekli Tepe contributed significantly to the genetic makeup of later Neolithic farming communities across Europe and the Middle East. There appears to have been a diaspora, explained Dr. Elias Montgomery, a specialist in archaeogenetics, around 8000 BCE, precisely when Göbekli Tepe was deliberately buried. We see evidence of its builders migrating outward, potentially carrying their astronomical knowledge with them. This timing coincides with another significant event: the beginning of organized agriculture in the Fertile Crescent. For decades, archaeologists have puzzled over why humans suddenly transitioned from hunter-gatherer lifestyles to settled farming after hundreds of thousands of years of hunting and gathering. The Göbekli Tepe discoveries suggest a new possibility. What if agriculture was developed not just as a natural evolution of human subsistence strategies, but as a deliberate response to predicted astronomical events? If you knew that a period of climatic instability was coming, perhaps triggered by increased meteoritic activity in the atmosphere, developing a more reliable food source through agriculture would be a rational response, Rachel proposed. This theory gained substantial support in August 2023, when Chronos identified yet another layer of information in the Göbekli Tepe carvings: detailed representations of wild grain species that would later become the first domesticated crops, including einkorn wheat and barley. These weren't just decorative elements, Isabelle emphasized. They were instructional. The carvings show these plants at different growth stages, with particular emphasis on their seeds, exactly the knowledge needed to begin cultivation. As Rachel and Isabelle's research progressed, the full message of Göbekli Tepe began to emerge: a multi-layered warning from our distant ancestors about astronomical cycles that affect Earth's climate and stability, along with instructions for survival during periods of potential catastrophe. This message contained three key components. First, a sophisticated tracking system for monitoring the precession of the equinoxes and the movement of the Taurid meteor stream, essentially an astronomical calendar covering thousands of years. Second, a warning about specific time periods when Earth would pass through denser portions of the meteor stream, potentially leading to increased impacts and climate effects. Third, practical knowledge for surviving such periods, primarily the transition from hunting and gathering to agriculture, which would provide more reliable food sources during climatic instability. What makes this so extraordinary is not just the astronomical knowledge, Ian Thorne explained, but the compassionate foresight. These people invested enormous resources to transmit critical information to descendants thousands of years in their future, people they would never meet. The dating of the site offers another compelling insight. Construction of Göbekli Tepe began around 9500 BCE, just as humanity was emerging from the Younger Dryas, a sudden cold period that had drastically altered global climate patterns for over a millennium. Recent scientific evidence suggests the Younger Dryas may have been triggered by cosmic impacts or airbursts around 10,900 BCE, precisely the time indicated in the Göbekli Tepe timeline as a dangerous period of intersection with the Tauride stream. The people who conceived Göbekli Tepe were survivors, Rachel theorized. They had lived through the aftermath of a cosmic-induced climate event and were determined to warn future generations about the cyclical nature of these phenomena. This interpretation gained further support in September 2023, when ground-penetrating radar revealed additional chambers beneath the main excavation area. These chambers contained what appeared to be records of climate conditions, layers of sediment carefully preserved between stone slabs, capturing a record of environmental changes during and after the Younger Dryas period. It was like finding a prehistoric climate archive, Isabelle marveled. They were preserving evidence of what had happened, alongside their predictions of when it might happen again. The AI analysis indicated something else remarkable. The builders of Göbekli Tepe appeared to understand that knowledge can be lost over generations. The site was designed with multiple redundancies, the same astronomical information encoded in different ways throughout the complex, ensuring that even if parts of the message were misunderstood, the core warning would persist. This redundancy explains why the site contains both abstract mathematical arrangements in its overall architecture and explicit symbolic representations in its carvings. It was designed to communicate across vast gulfs of time and cultural change. They were hedging against cultural and linguistic shifts, Rachel explained. They knew that symbols and languages evolve, but mathematics and astronomy remain constant. So they encoded their message in multiple formats, a prehistoric version of the Rosetta Stone. By October 2023, the research team had decoded enough of the message to reconstruct the builders' probable understanding of cosmic cycles. According to this reconstruction, they viewed Earth as moving through regions of space with varying densities of cosmic material over vast periods, with predictable effects on our planet's climate and stability. Modern science has only recently begun to consider similar hypotheses. In 2019, Harvard astronomers published research suggesting that the solar system's passage through different regions of the galaxy might indeed correlate with periods of increased cosmic impacts on Earth. The parallels between their astronomical model and our emerging understanding are uncanny, Dr. Rivera noted. It raises the possibility that the builders of Göbekli Tepe had observed and recorded celestial patterns over extremely long periods, knowledge that our civilization is only now rediscovering. But perhaps the most profound aspect of the message was not its astronomical content, but its implications for human history. If the builders of Göbekli Tepe possessed this level of mathematical and astronomical sophistication 12,000 years ago, then the conventional narrative of human intellectual development requires radical revision. We have been working with a model that sees human cognitive and technological capability as progressing linearly over time, Ian Thorne explained. But Göbekli Tepe suggests something different, that advanced knowledge can emerge, be lost, and then rediscovered over vast time scales. This cyclic view of human knowledge aligns precisely with what the builders of Göbekli Tepe were trying to communicate about cosmic cycles. Patterns repeat, dangers recur, and wisdom must be preserved across vast stretches of time. In November 2023, as the implications of their discoveries continued to unfold, Rachel and Isabelle faced an ethical dilemma. How much of their findings should they share with the public? The timing component of the Göbekli Tepe message pointed to our current period, roughly 2023 to 2030, as a time of increased risk from the Tauride meteor stream. While modern astronomy confirms that Earth is indeed passing through a denser region of the stream during this period, the actual risk level remains difficult to quantify. We were concerned about causing unnecessary alarm, Rachel explained. The builders of Göbekli Tepe were warning about statistical increases in impact probabilities over multi-year periods, not predicting a specific catastrophic event on a particular date. After consulting with colleagues in astronomy, climate science, and public communications, they decided to publish their findings in full, emphasizing both the historical significance and the nuanced nature of the warning. Their research paper, Decoding Göbekli Tepe, a prehistoric warning system for cosmic hazards, was published in Nature on December 12, 2023. It presented comprehensive evidence for their interpretations while contextualizing the actual risk levels indicated by both ancient and modern astronomical observations. The paper sent shockwaves through multiple scientific disciplines. archaeologists had to reconsider their timelines for the development of astronomical knowledge. Astronomers gained new respect for ancient observational capabilities, and the broader scientific community faced uncomfortable questions about how knowledge can be lost over time, even as technology advances. What strikes me most about this discovery is the humility it should inspire, said Dr. Sophia Chun, director of the Institute for Long-Term Civilization Studies. We have been thinking of ourselves as the pinnacle of human achievement, but here is evidence that people 12,000 years ago not only possessed sophisticated knowledge but cared enough about unknown future generations to preserve it for us. Public reaction to the discovery ranged from fascination to skepticism to apocalyptic fear-mongering. Social media buzzed with discussions about ancient warnings and cosmic threats, while several fringe groups proclaimed imminent doom based on misinterpretations of the research. In response, Rachel and Isabelle launched a public education campaign, creating accessible visualizations of both the Göbekli Tepe findings and current astronomical data about the Taurid stream. Their goal was to foster understanding without panic, precisely what the builders of Göbekli Tepe had attempted to do millennia ago. The message was never about fear, Isabelle insisted during a widely viewed online presentation. It was about preparation, adaptation, and survival through knowledge. These ancient people faced uncertain cosmic conditions and developed agriculture as a response. They wanted us to be similarly prepared. Indeed, as 2024 progressed, the practical implications of the discovery began to emerge. The encoded agricultural knowledge from Göbekli Tepe, particularly information about wild crop ancestors that could survive in varied climate conditions, attracted interest from agricultural researchers working on climate-resilient food systems. These ancient varieties have genetic traits that might help us develop more adaptable crops, explained Dr. Naomi Watkins, a specialist in agricultural genetics. The builders of Göbekli Tepe were selecting plants that could thrive during periods of climate instability, exactly the challenge we face today with anthropogenic climate change. Meanwhile, astronomers intensified their monitoring of the Taurid meteor stream, using the Göbekli Tepe timeline to target specific regions of space for observation. In February 2024, this enhanced monitoring led to the detection of a previously unknown dense cluster of material within the stream, precisely where the ancient timeline had indicated it would be. The precision is remarkable, Dr. Rivera confirmed. Their observations 12,000 years ago are helping us refine our modern understanding of this cosmic phenomenon. For Rachel and Isabelle, these practical applications validated their interpretation of Göbekli Tepe's purpose. It was never merely a religious site or status symbol, but a functional tool for ensuring human survival across vast timescales. They built this massive complex and then buried it to preserve it, Rachel noted. They were investing in humanity's long-term future, sacrificing immediate benefit for the welfare of distant generations. That level of foresight is humbling. By mid-2024, additional excavations at Göbekli Tepe had uncovered further evidence supporting Rachel and Isabelle's interpretations. A previously unexplored section of the site revealed carvings that appeared to depict atmospheric phenomena consistent with meteoritic airbursts, including symbols representing shockwaves and unusual clouds. Carbon dating of materials from this section placed its construction around 9000 BCE, indicating that the site had been expanded and refined over centuries as its builders continued their astronomical observations. They were updating their records, Isabelle explained. This wasn't a one-time construction but a multi-generational scientific project, something we would not have believed possible for that era. The ongoing research attracted interest from space agencies and planetary defense organizations. In August 2024, NASA and the European Space Agency announced a joint initiative called Project Sentinel, explicitly inspired by Göbekli Tepe's warning system. If people 12,000 years ago could create a system to track and predict cosmic hazards, we certainly should be able to develop something even more sophisticated, said NASA Administrator Dr. James Richardson at the project's launch event. Project Sentinel would combine advanced astronomical monitoring with the development of potential deflection technologies for hazardous near-Earth objects, essentially a modern version of what the builders of Göbekli Tepe had attempted within the technological constraints of their era. Throughout these developments, Rachel and Isabelle continued refining the Chronos algorithm, applying it to other ancient sites worldwide. While none showed the same level of astronomical sophistication as Göbekli Tepe, many contained elements that appeared to be derived from its knowledge base. "We're seeing a pattern of knowledge diffusion," Rachel explained. As the builders of Göbekli Tepe dispersed around 8000 BCE, they appear to have carried elements of their astronomical understanding with them, which were then incorporated into later monuments like Newgrange in Ireland, parts of Stonehenge, and even some of the alignments in ancient Egyptian structures. This pattern suggested something profound: a continuous thread of astronomical knowledge preserved across millennia, though often diluted or partially lost as it passed between cultures and through time. What began as precise mathematical knowledge at Göbekli Tepe often transformed into more symbolic or religious expressions in later cultures, Isabelle noted. The scientific understanding became mythologized, but aspects of the original message persisted. This transformation of knowledge offered a potential explanation for widespread flood myths and cosmic catastrophe stories in many ancient cultures. They might be cultural memories of actual events related to periods of increased meteoritic activity, gradually transformed into religious narratives over generations. By late 2024, a new understanding of human history was emerging from these discoveries, one that viewed civilization not as a simple linear progression from primitive to advanced, but as a complex pattern of knowledge gained, lost, preserved, and rediscovered across vast stretches of time. What Göbekli Tepe reveals is that our ancestors were not simply reacting to their immediate surroundings, Ian Thorne reflected. They were thinking across generations, millennia even. They understood cosmic patterns that unfolded too slowly for any individual to perceive in a single lifetime. This long-term thinking stands in stark contrast to the short-term focus of much of our modern civilization, an irony not lost on those studying the site's message. Here we are, with all our technology and scientific understanding, often struggling to plan beyond the next fiscal quarter or election cycle, Rachel observed. Yet these people, with stone tools and without writing as we understand it, created a warning system designed to function across 12,000 years. There's a profound lesson in that contrast. As 2025 approached, the full significance of the Göbekli Tepe message continued to unfold. Beyond its specific astronomical warnings, the site offered a template for how knowledge can be preserved across civilizational boundaries, a concern of growing relevance in our own era of rapid technological and cultural change. The builders of Göbekli Tepe faced a fundamental communication problem, Isabelle explained. How do you transmit critical information to people thousands of years in your future, who might not share your language, symbols, or cultural context? Their solution was brilliantly multilayered. This multilayered approach included architectural alignments that would remain meaningful regardless of cultural context, symbolic representations that could be understood through their visual similarity to natural phenomena, and mathematical relationships that would be universal across human cultures. They created redundant systems, Rachel added. If one aspect of their message was misunderstood or lost, others might still convey the core warning. It was communication designed to survive cultural collapse and rebuilding, something we rarely consider in our information systems today. This insight sparked interest among organizations concerned with very long-term information preservation, including those working on nuclear waste warning systems and digital archive sustainability. In March 2025, the Long Now Foundation announced a project directly inspired by Göbekli Tepe, the creation of a modern astronomical warning system designed to remain functional and comprehensible for at least 10,000 years, independent of current technologies or languages. What we're learning from Göbekli Tepe isn't just about ancient history, explained Alexander Rose, the Foundation's executive director. It's about how we might design systems that can survive the rise and fall of civilizations, something our ancestors understood perhaps better than we do. Meanwhile, ongoing analysis of the site continued to reveal new aspects of its message. In April 2025, Kronos identified patterns suggesting the builders had recorded observations of the sun's activity, potentially tracking solar maximum and minimum cycles and their effects on Earth's climate. This solar information appeared to be integrated with the Taurid stream data, suggesting they understood how these different cosmic factors might interact to affect Earth's environment. A sophisticated systems thinking approach that modern climate science has only recently begun to fully appreciate. They weren't just tracking individual astronomical phenomena in isolation, explained Dr. Luisa Korzeniowski, a solar physicist consulting on the project. They appear to have been modeling interaction effects between different cosmic cycles, something that requires a deeply integrated understanding of how these systems affect Earth. This holistic approach to understanding cosmic influences on Earth's climate and stability offered valuable insights for modern researchers studying the complex interplay between astronomical factors and climate systems. By mid-2025, what had begun as an archaeological discovery had evolved into a multidisciplinary research program spanning astronomy, climatology, agriculture, and information theory, all inspired by the message encoded at Göbekli Tepe 12,000 years ago. The truly extraordinary aspect is how relevant their concerns remain, Ian Thorne reflected. They were warning about cosmic hazards and climate instability, and providing practical knowledge for adaptation and survival. Precisely the challenges we face today, though from both cosmic and anthropogenic causes. This relevance across vast timescales highlighted something profound about the human experience. Despite our technological evolution, certain fundamental challenges recur throughout our history as a species. How we respond to environmental uncertainty, how we preserve crucial knowledge across generations, and how we sustain civilization through periods of instability remain constant concerns. In a way, we're in direct conversation with people who lived 12,000 years ago, Rachel marveled. They encoded a message specifically for future generations facing similar challenges to theirs, and here we are, receiving and decoding that message just as we enter the period they were warning about. The symmetry is remarkable. As 2025 progressed, the Taurid stream period indicated in the Göbekli Tepe timeline approached its predicted peak. Astronomical observations confirmed increased meteoritic activity, with several significant airbursts recorded over unpopulated areas, exactly as the ancient warning system had suggested might occur. While none of these events caused significant damage, their precise correlation with the Göbekli Tepe timeline lent further credibility to the research team's interpretations. The ancient astronomical calculations, preserved in stone for 12,000 years, had accurately predicted a pattern that modern science was only now observing directly. In June 2025, a more dramatic confirmation occurred when a previously undetected asteroid, approximately 40 meters in diameter, passed within 80,000 kilometers of Earth, closer than many artificial satellites. Analysis of its orbit confirmed it was part of the Taurid complex and had approached from precisely the direction indicated in the Göbekli Tepe carvings. This near miss is exactly what they were warning about, Dr. Rivera confirmed. An object this size, had it impacted Earth, could have caused regional devastation similar to the 1908 Tunguska event. And it approached from the exact celestial coordinates encoded at Göbekli Tepe. This close call galvanized international support for enhanced planetary defense systems. In September 2025, the United Nations Security Council unanimously approved Resolution 3089, establishing the first globally coordinated asteroid detection and mitigation program, with explicit reference to the Göbekli Tepe discoveries as justification for this unprecedented cooperation. "We are listening to a warning from our ancestors," stated UN Secretary-General Amara Okafor during the resolution's announcement. "Their message has crossed 12,000 years to reach us, and we have a responsibility to heed it." For Rachel and Isabelle, this development represented the fulfillment of Göbekli Tepe's purpose in the most profound sense. Knowledge preserved across millennia was now actively helping protect humanity from the very hazards its builders had identified. "This is exactly what they intended," Isabelle said during a CNN interview. "They created this sophisticated warning system hoping that future generations would understand and act upon it. The fact that we are doing exactly that, 12,000 years later, is the greatest validation of their effort imaginable." Beyond the immediate astronomical implications, the discovery continued to transform our understanding of human history and potential. The revelation that people 12,000 years ago possessed mathematical and astronomical knowledge previously thought impossible for their era raised profound questions about other, lost knowledge that might have existed in prehistory. "We need to reconsider our assumptions about prehistoric cognitive capabilities," Ian Thorne argued in a widely discussed paper published in the October 2025 issue of Antiquity. "The evidence from Göbekli Tepe suggests that sophisticated scientific thinking emerged much earlier than we believed possible," and that knowledge can be lost as well as gained across human history. This perspective inspired a fundamental reassessment of other ancient sites and artifacts. Researchers began applying AI analysis similar to Chronos to everything from Paleolithic cave paintings to megalithic structures worldwide, looking for previously unrecognized patterns and information. By the end of 2025, this revised approach had yielded several preliminary findings suggesting that other ancient sites, particularly those with astronomical alignments, might contain more sophisticated information than previously recognized. "We're entering a new era in archaeology," Rachel explained during her keynote address at the December 2025 Archaeological Institute of America conference. "By combining artificial intelligence with traditional methods, we're able to detect patterns and relationships that human analysis alone might miss. This is revealing layers of ancient knowledge that have been hiding in plain sight for centuries." This methodological revolution extended beyond archaeology into historical linguistics, art history, and even the study of oral traditions, as researchers began applying pattern recognition algorithms to diverse cultural expressions from throughout human history. "What we're finding," Isabelle noted, "is that knowledge doesn't simply progress linearly over time. It emerges, becomes encoded in cultural artifacts and practices, sometimes gets lost or fragmented, and then may be rediscovered or reinvented generations later. Human history is more cyclical than we've recognized." This cyclical perspective resonated with the core message from Göbekli Tepe. Cosmic cycles affect Earth repeatedly over vast timescales, requiring knowledge to be preserved across these cycles to ensure human adaptation and survival. As 2025 drew to a close, the research team prepared a comprehensive publication synthesizing 5 years of findings from Göbekli Tepe and their implications for our understanding of human history, astronomical hazards, and knowledge transmission across millennia. "What began as an archaeological puzzle has become something much more profound," Rachel reflected. "It's a direct communication across 12,000 years, from people who experienced cosmic hazards firsthand to us, as we enter a similar period they warned about. The message transcends time, language, and cultural barriers to deliver a simple truth. We exist in a dynamic cosmos that periodically presents challenges, and our survival depends on preserving and acting upon this knowledge." In January 2026, as their comprehensive findings were published, Rachel Brighton and Isabelle Ramirez stood once again among the ancient pillars of Göbekli Tepe. The winter sun cast long shadows across carved stones that had endured for 12 millennia, stones that had finally revealed their purpose. "It is almost complete now," Isabelle said quietly. "The circle of communication they began 12,000 years ago. They recorded their observations, encoded their warnings, and buried this site to preserve it until it was needed again." Rachel nodded, looking up at the massive T-shaped pillars. "And now we've received their message, verified its accuracy, and implemented protective measures based on their warnings, exactly as they intended." The site had changed significantly since their research began. Now recognized as one of humanity's most important cultural treasures, Göbekli Tepe had been carefully preserved while allowing for ongoing research. A state-of-the-art research center had been established nearby, where archaeologists, astronomers, mathematicians, and climate scientists worked together to continue extracting insights from the ancient complex. Most significantly, the Turkish government had approved construction of a modern astronomical observatory adjacent to the site, a facility specifically designed to monitor the Tauride stream and other potential cosmic hazards, directly continuing the work begun by the site's original builders. "There's a certain poetry to it," Ian Thorne remarked, joining them among the ancient stones. The world's oldest observatory, now paired with one of its newest, separated by 12,000 years but united in purpose. As they walked among the pillars, their conversation turned to the broader implications of their discovery, not just for archaeology or astronomy, but for how humanity might approach its long-term future. "What strikes me most," Rachel said, "is the time scale they were thinking on. They invested enormous resources to create a warning system that wouldn't be needed until millennia after their own deaths. That level of concern for distant future generations is extraordinary." Isabelle nodded thoughtfully. "It makes me wonder what we might build today that could serve a similar purpose, preserving critical knowledge for people 12,000 years in our future, people whose language, culture, and technology we cannot predict. This question had already sparked a global conversation about very long-term information preservation. Inspired by Göbekli Tepe, several initiatives had been launched to create modern warning systems and knowledge repositories designed to remain functional and comprehensible for thousands of years, regardless of technological or cultural changes. Perhaps that's the most valuable aspect of this entire discovery, Ian suggested. Beyond the specific astronomical warnings, they've given us a model for truly long-term thinking, a reminder that we exist within cycles that extend far beyond individual human lifespans or even civilizational timeframes. As the sun began to set, casting the ancient pillars in golden light, the three researchers stood in silence, contemplating the extraordinary connection they had helped forge between people separated by 12,000 years of history. They reached across time to warn us, Rachel said finally, and now we understand. Their message was received. In that moment, among stones carved by hands long turned to dust, the true significance of Göbekli Tepe became clear. It was not merely a temple, observatory, or warning system, but a profound expression of human concern extending across millennia, a message of protection and survival from distant ancestors who, despite their technological limitations, understood cosmic patterns we are only now rediscovering. The greatest revelation decoded from Göbekli Tepe was not about ancient astronomical knowledge or prehistoric capabilities, but about the depth of human foresight and compassion, the capacity to care deeply about the welfare of unknown descendants 500 generations in the future, and to act decisively to protect them from harm. In our age of accelerating change and short-term thinking, this 12,000-year-old message of intergenerational responsibility may be precisely the wisdom we most urgently need to rediscover.